Our course today is going to be about iPhone 7 backlight circuit. The display functionality of the screen is fulfilled by LCD and backlight, with LCD being activated in the system. The backlight is also activated at the same time. First, the system provides main power supply and one rail of 1.8 volts system voltage to the backlight driving IC. Meantime, CPU sends drivers and control info to the backlight driving IC via I2C bus. In addition to the function control of backlight driving IC via I2C bus, CPU also controls the output power of the IC via DWI bus, so as to adjust brightness of the backlight. Once the backlight driving IC is activated, it will form a boost circuit with M2800, D3702, D3701, C3725, C3704, C3706, and C3705. The boost circuit will then generate a rail of backlight voltage and output it to the backlight of the screen. The backlight voltage is divided into two rails after entering the screen. Backlights on the left side and the right side of the screen are then driven to glow by the two rails respectively. The two rails of voltage will then pass through an inductor and return back to the backlight driving IC respectively. If either one of the two inductors fails, then the screen might run with no backlight issue. Now let's move to diagnosis and maintenance of the backlight circuit. First, replace the screen, power on and test. If the screen runs with normal display while no backlight, then the backlight circuit has malfunctioned. Continue to run cosmetic inspection of the logic board and check whether backlight circuit's relevant area is normal. If nothing goes wrong, run diode mode measurement of pin 35 and 37 and 39 on J4502. 1. If there is abnormal value measured, continue to measure FL3901, FL3902, and FL3903. If any of the three inductors is abnormal, we can just replace the abnormal inductor. If the problem remains unresolved, we need to replace the backlight boost IC U3701. If the three inductors are normal, we can detach U3701 from the board and measure circuits from pin A1 and B1 and C1 to FL3901 and FL3903 and FL3902. 2. If the measured value is normal, continue to run diode mode measurement of D3701 and D3702. 1. If there is abnormal value measured, we can replace the diode bearing abnormal value. If the problem still remains unresolved, follow maintenance steps of the opposite condition listed below. 2. If the measured value is normal, detach U3701 from the board and run diode mode measurement of pins C2 and C3 and B2 and A2 and D1. If the measured value is normal, we need to replace U3701. If the problem still remains unresolved, then CPU has been pseudo-soldered or damaged. If the measured value is abnormal, measure circuits from R4701 and R4702 to pin A2 and pin B2 of U3701. If the problem still remains unresolved, then CPU has been pseudo-soldered or damaged. Common fault components of the backlight circuit. Malfunction of U3701 will result in issues like no backlight, iPhone stuck on Apple logo issue. Malfunction of M2800 will result in no backlight issue. Malfunction of D3702 or D3701 will result in no backlight issue. Malfunction of C3725, C3704, C3706 or C3705 will result in issues like no backlight, backlight flickering, or dim backlight. Malfunction of FL3902 or FL3903 will result in no backlight issue. Malfunction of J4502 will result in issues like no display, no backlight or abnormal display of the phone. And this is our detailed explanation of how iPhone 7 backlight circuit works. Feel free to visit our official website www.rewatechnology.com. See you next course.